Alright, in the previous video, we learned the basics of rigid body in Blender and how physics works on objects. In this part, we're going a bit deeper into the collision section. We'll see how changing the collision shape affects the way an object lands, and we'll take a look at options like box, cylinder, sphere, convex hull, compound, and mesh. So, let's see how this actually works. In this part of the rigid body tutorial, we're going to look at the collision section. In the collision section, we can actually change the shape of the moon mesh and change it to the state we want the physics to take. For example, in the shape section, we can change it to a box state so that when it lands, it acts as a box and lands. We can change it to a cylinder state. As you can see in the wireframe, it is changed to a cylinder state. We can even change it to a circle state so that it acts as a circle when it lands. Apart from these shapes, there is a section called the Convex Hull, which connects the vertices around the moon mesh to get a shape that Blender wants and makes it fall. The mesh state is also the mesh itself. Without any additional shapes, the mesh itself is the cream. As you can see, Susan lands normally. To better understand the compound hull, I'm going to open a node here. As you can see, if I add the concave hollow here, it shows the actual shape of it when its vertices are connected, and if we want to show them in wireframe mode. To better understand it, we see here that all the vertices are connected from the outside. And again, to see it better, we're going to add a join geometry here and connect the first node to it. So if we go into wireframe, we see Susan how these vertices are formed around her. And exactly what I mean by her landing. Well, we're not going to do anything with this for now, and we're going to close this page. Let's go back to our timeline. And the next part, which is the shape in this case, the compound part. What does compound mean? Compound means that if we compound an object or mesh, it means that its landing physics will be taken from that, in fact, the object that is its child. And if I come here and make this cube the child of this Susan, we see that when it lands, Susan doesn't have a mesh of her own. It doesn't have physics, and her physics is taken from this box, this cube. Inside the mesh section, we have three states. The diff mode, which is the medium mode that I'm explaining. Now the base mode, the simple mode without any modifiers. The diff mode is a state where, if we change the mesh there with a modifier, for example, I'm here with Susan. For example, I add a subdivision, and now I'll give it a little lift and change its physics, and if we go back into the animation again, we'll change its form a little. We see that inside the diff mode, when the source is on the diff, the mesh of the moon is inspired by it, and it lands like that. And the next section is the final. This means that it actually gives us the final result, where all the modifiers and all the changes we apply to our mesh are saved in the final section. As you can see, it lands exactly as it is, and its physics are more realistic than the other modes, if we want to make any changes to it. That's it for this part. Next up, we'll dive into friction and bounciness and make our physics feel more realistic. See you in the next video.